All right, guys, we are going to start our section on conics today. Conics are a type of a result that we get when you cut this double-naped cone with a plane. Now, I know that sounds a little bit crazy. That's why I tried to draw. I have pictures here, okay? And I'm giving these to you guys in class so that you can glue these in your notes. But what you're seeing here is kind of the result on how you get the different types of conics. This is what I mean by a double-naped cone. We have these two cones that are like end to end, and they make this interesting relationship that we're able to like get a lot of properties from. If you were to slice that with a plane, right, straight through here, kind of going at this angle, then the way that that plane hits that curve or hits that cone is it hits at this parabolic type of shape. Now, of course, you're seeing all of it shaded on the inside, but the part that's truly the conic that we're studying is just the part where it's intersecting that cone on the outside. Imagine that the cone is hollow and where that plane is cutting through and hitting that cone, that's the parabola, and that's our conic section. So there are lots of different ones. You can look on our textbook, Figure 2, page 493. You're going to see a lot of different things, of different types of intersections, but these are the ones that we're specifically studying for right now, and but you can still look at that picture. They have some nice pictures in there of each one individually instead of all on one thing. So if this is overwhelming, you can go look at that picture, okay? So anyways, that's for parabola. Now, what if I slice at a different angle, right? If I were to slice this just straight horizontal, that's when we result in this little circle, right? You just imagine if you're looking at that head on, it would be a perfect circle if this intersected straight horizontal. But what if I do that just at a slant, just a little bit of a slant? Well, if I do that at just a little bit of a slant, then we get this thing called an ellipse. It's like an oval, okay? Now, if I did this like almost straight down or even just at an angle where it hits both cones, right? If it hits at an angle where it hits both cones at the same time, that's when we have this thing called a hyperbola. And you see these two, it's all like parabolas that are going away from each other. That's what you're seeing there. Okay, these are the ones that we are going to be studying over this section. Our focus in this video is to focus on parabolas, and we're going to see parabolas in a slightly different light than what we have seen in the past. So just make sure you're understanding that this is not exactly the same way that we've dealt with or looked at parabolas in the past. It's just kind of like a fresh take, okay? All right, so with that being said, let's get our definition of a parabola in this context, okay? All right, we got several different terms here, okay? That's what we got. So a parabola, it is the set of all points in a plane equidistant from this line we call a directrix and a point we call the focus. And you can see here in this little picture, okay? I can zoom in a little bit. Let's see if this helps. Our parabola is what I have here in black. Now, I'm not a great artist, so this is the best I could do, but our parabola is what we're seeing here in black. This focus, okay, is a point on the inside of that curve, and this directrix is a line on the outside. Now, again, I'm not much of an artist, so I did what I could, but it is still not perfect. The focus and the directrix are supposed to be equidistant from the parabola. So that means that this would be the same distance as here. Again, I don't draw well. Also, if I were to draw a point from that focus to anywhere on the parabola, that distance is the same to the directrix. So these would be congruent, again, if I could draw. All right, we also have a couple other things over here. I'm going to zoom back out. Okay, we've got what's called a focal axis, or we just tend to just call it the axis or axis of symmetry. There's lots of different terms to talk about that. That's what you're seeing go through the focus, the vertex, and everything in here. And then we also have our vertex, which is, again, that turning point of your parabola. That's something we've always seen as well. It's where the parabola intersects the axis. Okay, also the turning point. Okay, that focal axis. One fun fact here, and I don't know if you guys remember what this symbol means, but it means perpendicular. So if you'd rather write the word perpendicular, you can. I just didn't want to try to write that big long word in this small section, so I use the symbol for it. But that does mean perpendicular. So your line of symmetry, or that axis, is perpendicular to your directrix. And that's why you see I've got a little right angle drawn right in here. Okay. All right. Also, you may have noticed that I did mark this with little p's to talk about the distance between the vertex and the focus, the distance from the vertex to the directrix. So what p is, just what we're going to be referencing as p throughout all this. P is the distance from the vertex to the focus. We're just going to leave it at that. It's also a similar distance from, or the same distance from that vertex to the directrix, but I'm just going to keep it as the focus. Okay, now I also have for you guys to glue into your notes when you're in class. I also have you guys these little foldable things. Okay, so we're going to focus first when we have a parabola that has a vertex at 0, 0, just like you see in this image right here. So this vertex at 0, 0, I'm going to maybe mark that, make that a little bit more prominent, okay? But that is what we're looking at right there. Okay, when that's the case, we have these properties just in here, okay? Or these little equations that we're going to work with. If it's a parabola that opens up or down, then you're going to see the equation in that standard form that we're going to use. It will be saying x squared equals, and then there's this 4py. Well, remember what p is representing. P represents the distance from the vertex to the focus. So this is a different way to look at an equation for a parabola, right? We have seen different parabolic equations in the past. This is a new take. Okay, so when we're looking at it in this context where we're dealing with the focus and the directrix and all this, then we're going to use this form of the equation. All right, so 4py, that's equal to x squared. Okay, whereas if it opens right or left, notice what the difference is. It's y squared equals 4px. So those will be swapped, and that's what causes it to open horizontally instead of vertically. All right, you're going to notice a few other differences between these. So the focus, if you know what your, and again, this is for where the vertex is at 0, 0. If it's somewhere else, it's a whole nother can of worms, okay? But if your vertex is at 0, 0, then we're going to use this where our focus will be at 0p, okay? And then, so if it opens up, it would be 0, and then it would be a positive p, whereas if it opens down, that would be 0 and a negative number, okay? Our directrix is going to be y equals negative p, so the opposite of p, because your directrix is on the opposite side of the vertex than the focus was, okay? So if the focus is at 0p, the directrix is going to be the opposite of that. It's going to be y equals negative p. All right, if we have a focal length, we're going to talk about the focal length, which is discussing the distance from the vertex to that focus. Okay, that's what P is. So that's why you're seeing that here. And then focal width is this absolute value of 4P. Okay, focal width is acting as if I was going to draw straight from here out to the side, straight out. Okay, what's the length there? That's going to be 4P. If you're opening right or left, some of these things get changed around. So your focus is going to be P0. Your directrix is X equals negative P. Notice how that's different. Our axis would be on the X-axis. Focal length is still P, and the width is still absolute value of 4P. So that doesn't change. All right. Now, Let's talk about how this changes if we have a center at HK. Now, like I did on the last one, I think I'm going to mark this. We're going to go down here and say, okay, this is my vertex. This is the vertex HK. Yeah? All right. So when we have that, I want you to think about what's going on. We've taken that parabola, you think of from 0, 0, and it's been transformed. So it may have been moved, it would have been moved left or right? It's not going to be in the same position. So instead of just using plain old x and y, like what we had on these equations, we're going to talk about h and k being our horizontal and our vertical translations. Okay, so it's going to look a little different in the equations. All right, now I want us to look at these kind of side by side for a second, just the ones that go up and down and up and down. So on the up and down with the vertex of 0, 0, we had x squared equals 4py. Now, if I want to translate that, I'm just moving it left, right, up and down. Then the way that I need to adjust this is I need to add or subtract a number with x to move it horizontally. And I need to add or subtract a number with y to move it vertically. That is literally the only change. Although this equation looks more messy, that is literally the only addition. I mean, there's parentheses there, but that's just to show that that's been grouped with x or grouped with y. So as long as you recognize that this parabola is centered at HK, all this is a translation of what we had before, then it should be much more straightforward. You get a similar thing when we talk about opening right or left. The only difference is the fact that we're adding this h and k in here. Now watch out though, because when I have it in this order with the y squared and then the x over here, remember that k is always talking about the vertical shift. That's got to go with y. H is the horizontal shift. It's always got to go with x. Okay? All right. Otherwise, again, we're just looking at this as translations of what we had originally. Our focus will be at the point H and then K plus P, right? Because we've got to think about our vertex was at HK. Well, originally, if you looked back over here, our vertex would have been at 0, 0. But the focus is at 0P, right? Here, if my vertex was at HK, my focus is going to be at HK plus P, right? So we're using that same idea. Directrix is going to be y equals k minus p. Axis is x equals h. Focal length is still p. Width, still absolute value of 4p. That did not change. When it opens right or left, we end up with these switched around ideas, but still just the same concept. So think about the vertex. If that was at HK, right, but this thing is opening right or left, our focus is going to be at H plus PK. Our directrix is going to be on the opposite side of that. H or X equals H minus P. Instead of H plus P, H minus P, right? Y equals K would be your axis. Then again, we have P, an absolute value of 4P for the focal length and the focal width. All right, y'all, I know I just went through like a lot of notes. We have not really worked any examples. What I'm going to do is I'm going to break this up. My thought is that in class, this is going to take 2 days to get through because we need 1 day for notes and then probably 1 day just to work problems. So in the next video, I'm going to work through a few examples, okay? And we'll leave it at that. All right, we'll see you in the next one. Bye.